On the C-17 program, high-performance, self-directed teams are becoming the norm on the factory floor. They've been trained to use statistical methods to improve quality. Their focus is on preventing defects rather than just detecting them. Marina Pincus reports from Long Beach.
Over 9 million parts must be manufactured and assembled to build a C-17 airlifter. The challenge, of course, is to do it on time, with the highest quality, and at the lowest possible cost. But putting the systems and processes in place to accomplish that has been an ongoing challenge on the C-17 program from the outset. Dan Tulkin, C-17 Senior Manager of Production Processes, explains.
About 1989, when we started off on the C-17, we were driven for schedule. Make the product. We have to have a product to sell, and we threw resources at it. We threw money. We threw people, and we really would disregard to the rework and repair hours and the total dollar value as what we needed to win the program. As we started on reducing and downsizing and wanting to be more effective, we figured out that it's not just, get the mechanics to do a better job, but it's to train a mechanic, to give them more tools so that he or she in turn may be more effective.
Those tools are being provided to mechanics and other workers through a program-wide initiative called variability reduction. Throughout the program, teams of workers are being trained at problem solving, team building, shop math, blueprint reading, design of experiment, and statistical process control. The goal is to stabilize production processes and produce product within specification.
We are shifting the focus from detection to prevention. We're going from quality assurance in a sense where the quality person assures the product, which we know can't happen, to a prevention mode where the quality is built into the product because of the process.
The variability reduction program is being deployed through high-performance, self-directed teams. They're given responsibility to manage their own work and use the quality control methods they've learned. One of those teams is the Center Spar team. They locate panels, drill, seal, and install fasteners to complete the entire Center Spar section. Vinayak Rajagopal is Manager of Operation Process Control.
This particular team not only progressing in their self-directed team journey, and they've completed all the requirements to implement process improvement, and they successfully certified the process that they're performing by applying statistical process control tools to produce a first-time quality product by eliminating all the defects. A statistical process control tool is a very powerful tool, helps them identify different causes of variation, where the variation comes from. And that helps the mechanics to pinpoint the problem before it happens.
So we went out and we decided, well, if we're going to deploy statistical process control, then we better give them some tools that they can collect the data with and make it more user-friendly so they don't spend a lot of time plotting and charting by hand. We gave them data mites, we gave them Genesis data collection equipment, we gave them the software to support that statistical program, and we enabled them to perform those tasks on their own, actually to read the charts, to determine when they're out of spec, when they're out of control, and to print out, share the information with their teammates whenever they need it.
The transition to self-directed teams and the implementation of statistical process control is not easy. For one thing, the role of the manager has to change. What do managers have to do to make it work? J.R. Morris is manager of the Center Spar.
You have to let go of the fear to start with. You have to have trust and faith in the people that are assigned to you in those teams. Give them the responsibility and the accountability and the authority to go out and tackle what's wrong and let them fix it. Leave them alone. Let them do it. If they need you, they'll come and get you. You're there for backup, so serve your role and let them do their role.
There were other hurdles to overcome. Team members became impatient with the process when they didn't see immediate results. But after going through the learning curve and with management's continuous support, they began to see the improvements they wanted. Another hurdle was peer pressure.
A lot of teams out there that have not deployed were going over to the teams that have deployed and say, hey, you know, you're working yourself out of a job. Why are you doing this? This is not for you. You know, let management take care of this. You're not supposed to read charts. You're not supposed to look at gauges. That's an inspector's job. So they went back to the crews that said, hey, why are you doing this? They said, this is why we're doing it, because we now make greater latitude. We can make decisions. We can enhance the design of this product. We can go out and bring in new business, you know, and bid out for new business, and our jobs are actually more secure than they were before.
The only way to survive is by operating in a team environment, by application of some of these process improvement tools, and this is absolutely essential to support a factory of the future.
The variability reduction program is getting results. By exceeding the typical industry standard for process capability, the Center SPAR team was the first to receive Operator Process Control certification. In some cases, the teams that have certified their processes, total rework cost has been cut 30%. In others, span time is down from 30 to 15 days. By the end of 1996, 44 teams were deployed and certified 51 processes. We've heard from the managers. How do team leaders, inspectors, and mechanics feel about the program?
To get the thing to work smoothly, you got to communicate between not just the team, the people, production people on the floor, but everybody all the way to the top.
We do inspect our own work. It gives us a little bit more confidence in the job that we're doing, because we check it first, and then inspections come back and check the overall job.
We come out and make sure that the process is right, that they're doing. And if we find that the process is right, the bottom line is the job is usually right.
With the team process, that if somebody isn't carrying their weight, call them on it. We've got to hold each other accountable.
It's a lot better. It makes you as a worker feel more relaxed, you know, versus having your boss or some other honcho looking down your throat all day, you know?
I think they were maybe a little bit, I guess, not accustomed to the mechanics having much input or say-so, but as they see that we are serious, that we're committed, that we do definitely want to put out a good product and build it per spec, per blueprint, their ears, I think, started tuning in, and they now are listening.
We will get the job done. I mean, it's not a forceful type deal, but we know what we got to do, and we get the job done on time. Just like we tell JR, you are the boss, let us do the work, and JR, just leave us alone. We have a lot of fun doing it.
For Flight Times TV, I'm Marina Pincus.
That's it for this edition. I'm Donna Race. From all of us at Flight Times TV, thanks for watching.